All right, so as you guys probably understand, next step is going to be chapter 9. So I have a couple sets of notes here to go over sections 1 and 2 in chapter 9. The first section is talking about stoichiometry and talking about how we can use mole ratios and how we can relate different substances in a chemical equation. So we're going to use these mole ratios that we've talked about before. I tried to get you to do that already so it wouldn't be such a huge shock in this chapter when we start doing these huge stoichiometric calculations. So I've given you an introduction to all the different pieces. You just need to put it all together. So again, this first section actually is just defining composition stoichiometry, reaction stoichiometry, that stuff. But basically, all you need to know is that any two things in an equation can be related to each other. Whether it's mass or moles, right? Both of those things are related to each other in and of themselves. So just in practice, we've already started doing this. The mole ratios, if I had an equation like this generic one, 1A plus 2B gives me 3C, right? That means that 1 mole of A and 2 moles of B can make 3 moles of C, right? So if I have any given mole amount for A, I can relate it to B and C. If I had 2 moles of A, then I would make 6 moles of C. And that makes sense because I had twice as many A as the equation described. If I had 3 moles of A, then I'd probably make 9 moles of C, right? And so on and so forth. I can also relate A and B, obviously. So if I had 5 moles of A, I'd need 10 moles of B to react with it. Again, I was having you guys show your work in a certain way to do that. So if it was 5 moles of A to start, and I wanted moles of B, I'd put 2 moles of B here, and I'd put 1 mole of A underneath, because that's how I'm converting one thing into the other. That's a conversion factor. That shows work, and it helps me keep track of my work so I can figure out what I'm doing in the long run. Now, it might not have been absolutely necessary in this case. I might be able to tell you that you had 2.5 moles of A to start, and you'd say, oh, well, it'd make 5 moles of B. And you could do that in your head, and that's great. But when you do the whole problem in this chapter, you're never going to be able to do it in your head. It is not that simple, right? So you have to learn how to show your work appropriately so you can, first off, know what to do, but then secondly, actually see step by step and explain step by step what you're doing, right? So the full type of problem here is not going to be what we did before necessarily, because just in the last chapter, I had you change moles of one thing into moles of another. I had you change moles of A into moles of B or moles of C or whatever, right? But in this chapter, I'm going to add in a few more steps, right? Starting with a mass of A, how many grams of B are going to be formed? So an example like this, you're going to need to know a little bit more. You can't just use ratios from the equation, although you're definitely going to use ratios from the equation. You have that 1 to 2 ratio already for A to B. We're definitely going to use that for that second step. But in the whole reaction, I need to do multiple things. In the whole calculation, I need to do multiple things. So what's really going to happen here is maybe I'm going to tell you, okay, you have 22 grams of A. And I want to know at the end of the day, how many grams of B are needed to react with 22 grams of A. And you're going to use this process to come up with an answer. And what it's going to look like is this, right? I use this tool all the time because it helps me organize my work and understand what I'm going to do. If I wanted moles of A and I started with grams of A, I would need to know a gram amount for A to put down here to convert grams into moles. If I wanted to change moles of A into moles of B, I would need moles of A down here to go with moles of B to convert from one to the other. And if I want to cancel this mole of B label, I would put that down here, right? The whole idea is to get from grams of A all the way to grams of B, if that's what I want for my answer, that's what I need to do, that's what I need to accomplish with my work. So I just need to know how to do that step by step. Right? So in this work that I've shown here, this generic work, I have a couple different things, right? I have a mole ratio like we talked about before. I'm definitely going to put 2/1 in here. But I also have 2 gram-mole conversions, right? And we know how to do that too. This is what a molar mass was for, which I'm going to need to know to be able to answer this question. I'm going to need to know the molar mass of A. I'm going to need to know the molar mass of B. So that's something that would probably be given in this case, right? 1 mole of A apparently has a mass of 10 grams. I'm just making up numbers because A, B, and C aren't real things. But 1 mole of B has a mass of 7 grams, right? 1 mole of C has a mass of 8 grams, right? So if I wanted to get all the way from grams of A to grams of B, I'd follow a process and I'd show my work exactly as I showed in this generic example here. I would start out with the 22 grams of A that I was given. In order to change grams of A into moles of A, I would use a conversion factor, right? Which would be this factor over here. I need to use a molar mass because 10 grams is equal to 1 mole of A. Then I can convert grams of A into moles of A by dividing by 10. And then I need to change moles of A into moles of B. And again, like I said, we're going to use a ratio. We're going to use that 2-to-1 ratio. There's 2 moles of B that react for every 1 mole of A that reacts, right? And then we'll do one last step, right? We just covered a couple things. We used a molar mass. We used a mole ratio. Again, we related those 2 things in the equation above. And then finally, we're going to need to use 1 more molar mass, but it's a different molar mass because it's a different substance. And B apparently is 7 grams per mole. Oops, put the A label on it by accident. 7 grams of B is 1 mole of B. So I could use this string, I could use this work to come up with my answer. I have to take 22 times 2 times 7 and then divide that answer by 10, right? So if I use a calculator real quick, 22 times 2 times 7 divided by 10, that's going to give me an answer of 30.8, which again, because we learned how to do that a long time ago, we'd probably have to deal with sig figs. 22 only had 2 sig figs, so I can only have an answer with 1 sig fig. I'm going to answer with 31 grams of B, and that's what I was looking for to begin with, right? So again, I know this is really complicated. It looks complex, but as you do more and more examples of this, it starts to make more and more sense, right? You're just doing you're using the same ideas over and over again. It can be tedious sometimes. It takes a lot of work to do it, but it's not necessarily hard. As long as you can see what I was using each step along the way here, as long as you understand that I used 2 different molar masses and a mole ratio, and you knew where I got those things from, right? I made up the mole mass numbers in this case, but usually you'd get those off your periodic table. The mole ratio came from that balanced equation that I gave you, because that's what 1A means. 1 mole of A would react with 2 moles of B to make 3 moles of C. So this is an example, a generic example. We're going to do a lot more in section 2, but those are going to be different notes.